Welcome. In this video, we're going to discuss how to configure Layer 2 Etherchannel. And if you're new to the channel, this is just one video of many in a series for GNS3 labs for the CCNA certification. So if that interests you, you should subscribe and check out the rest of the videos in the playlist as well. And before we get into the Etherchannel configuration, we're going to talk a little bit about Etherchannel in general. We're going to go over what an Etherchannel is, how an Etherchannel works, the different Etherchannel negotiation protocols, Etherchannel load balancing, and then we're going to go through Layer 2 Etherchannel configuration, and we're going to demonstrate that on GNS3. And we're going to save Layer 3 Etherchannels for a different video. So first off, what is an Etherchannel? It is a technique for aggregating the bandwidth of physical links together. And there's a number of terms that you'll hear commonly used in the industry for Etherchannel. For example, port channels, link aggregation, NIC teaming, and channeling. If you hear those all basically mean the same thing, and that is Etherchannel. Now a little bit on how Etherchannels work. So Etherchannels have two parts. There's both a port channel interface and the member interfaces. And the port channel interface is a logical interface representing the link bundle, and the member interfaces are the physical links themselves. And the goal of Etherchannel is to hide the member interfaces from the upper layer protocols. And from the perspective of spanning tree, it's going to appear to be one 2 gig link rather than two 1 gig links. And the end result is that both links are going to forward active rather than active standby. And this is going to increase total throughput. And on this side here, we're just demonstrating the difference between the physical view and the logical view. This top pair of switches represents the physical view, as you're going to have two links between each of the switches. And then the bottom one represents the logical view, where logically it just looks like there's one link between the two switches. And here we've got the pros and cons of Etherchannel. One of the pros is that you get more speed out of your links, and you actually have more link layer redundancy. For example, if you had 4 links in one Etherchannel, a 4 by 10 gig link would have better resiliency than a 1 by 40 gig link. Because if one of 4 links fails, then you still have the 3 other links to forward traffic, whereas if you only have one link, then if that one fails, then you have nothing. Now, one of the cons, and I guess common misperceptions, is that flows cannot exceed the speed of an individual link. An individual flow can only go the speed of the underlying link. Meaning if you have 4 1 gig links bundled, individual flows going across that link could only go 1 gig. And that's because when the flows go across that link, it's just going to pick one of the member links to go across. And a good analogy that you'll hear quite often for this is how the link bundle is actually like having a 4-lane highway, whereas you can have 4 lanes of traffic, but you're not increasing the speed of each of the individual lanes. Each of the individual lanes still has to abide by the speed limit. And here we have the different Etherchannel negotiation protocols. The first of which is Port Aggregation Protocol, or PAgP. Then there is Link Aggregation Protocol, or LACP. And then there also is a static configuration, which means there is no negotiation. This is supported but not recommended. Now, comparing the two, PAgP versus LACP. PAgP is Cisco proprietary, basically Cisco's first implementation that LACP was based off of, and LACP is the open standard for link aggregation. So if you're not using Cisco switches, then that's what you'd use. And they both basically provide the same functionality, although they use different configuration. And the way that you set the protocol that you want across the Etherchannel is by using the modes, the Etherchannel negotiation modes. So here I have the general config. You use the channel group command, then you give it a number, and then you also declare the mode. And then that mode determines how the negotiation occurs. If you use the mode on, both sides of that Etherchannel would have to have the negotiation to on in order for it to function. And this basically means that there is no negotiation, and this is what we call turning it on statically. And then if you set the mode to desirable or auto, that's how you either initiate or listen for the PAgP protocol, and then you can set it to active or passive to initiate or listen for LACP. So what we have here is the Etherchannel mode compatibility. And so there's 5 different ways that you can set the modes in order for the Etherchannels to function. The first of which is on, in which both sides are set to mode on. The second of which is both sides are set to desirable. The third method there, we have one side set to desirable and one side set to auto. And so these second and third options is what you would use for PAgP. And then the fourth is active-active. And then the fifth would be one side can be active and the other side can be passive. And the fourth and fifth options would be for configuring LACP. For Etherchannel load balancing, the lag driver is responsible for the distribution amongst the links. STP and CAM tables see lag as the outgoing interface, not the individual members. And really what we mean by load balancing is how does the link aggregation protocol determine which one of the physical links to send a flow across when a flow is going across the link. And the different methods include source and destination MAC address, so using layer 2 information, source and destination IP address, using layer 3 information, source and destination layer 4 addresses, so it would be layer 4. And the load balancing method is locally significant and outbound, which means that each side of the Ether channel can negotiate differently. And here are a couple of the issues that you see with Etherchannel. The most common problem with lag is the order of operations. This means that the member links must agree on the parameters, and you cannot mix layer 2 and layer 3 ports. Ports also must match. This means that the ports can either be access or trunk ports, but they all have to be one or the other. They either all have to be access or they all have to be trunks. And when it comes to the configuration steps for layer 2 Etherchannel, there really only is 2 steps. The first of which is making sure that the underlying configuration is matched amongst the member ports, making sure that all the configuration is the same. And then on each of the interfaces, configuring the channel group command while specifying the number of the Ether channel, which is what identifies it, and then the mode. And that too also has to be the same amongst all of the member ports. Now I've got GNS3 pulled up in order to demonstrate the layer 2 Ether channel configuration. And the first thing I'm going to do is create a topology with 2 switches on it. I'm going to create 4 links between the 2 switches. And I've got my configuration up over here, and I'm going to demonstrate that we can create Ether channels with both trunk ports and access ports. And then we're going to go through the configuration options on how to use the 5 different combinations of modes for Ether channel. And I do think I'll be able to fit all of the configuration commands down in the description of the video, so if you want to use that and follow along, you should be able to. Now I'm going to start the devices and open up the consoles. All right, now I'm going to start applying the configuration. First, we're going to configure the host names, and then we're going to build the access ports and the trunk ports between the 2 devices. Oh, and then I'm also creating VLAN 10 so that they both have VLAN 10 on them. And then just real quick to verify, we're going to do show VLAN brief and show interfaces trunk to verify that we both have the VLANs that we want on the appropriate interfaces and that we have trunking set up on the appropriate interfaces. And then we're going to put in end so that we can just paste in these commands. Okay, so show VLAN brief. We created our VLAN 10, so that exists, and it is on both gig 00 and 01, which is what we wanted. And we do have the same exact thing on switch 2. And then show interfaces trunk. Both 02 and 03 are trunking and allowing VLAN 10 on the trunk, which is what we want. So I'll just give those a little bit more space. And the first thing that we are going to do is apply this configuration. Actually, let me just make this a little bigger. All right, so the first type of Ether channel that we're going to configure is using the static configuration, in which we just tell all ports to be in the on state, which means that it's not going to negotiate, it's just going to turn it on. And then the verification command for Etherchannel is going to be show Etherchannel summary. And we're just going to put a do in there so we don't have to exit out. Reading this output here, we have port channel 1 with S, right? And we can see up here in the command legend that we have an S equals layer 2. So each of these are layer 2 Ether channels. And U means that it's in the up state or in use. So that's what you want to see. That means that it's configured correctly. It is up. And then you can also see that these are the member ports for port channel 1, and these are the member ports for port channel 2. And we'll verify the other side of it on switch 2. And we have the same output, so that's what we want to see. So the second one we're going to do is desirable, and that's going to be PAgP, the PAgP protocol. We're going to use the same ports that we already have configured, and in order to do this, the first thing that we're going to do is shut down all of the ports on each of the switches, which is definitely what you're going to want to do. If you're going to change the configuration on an Ether channel, you generally want to shut down every time. And then on each of the individual ports, we're going to put this no command. We're going to no out the channel group command that we put in there previously. And then we're going to put in a new channel group command, giving it the same number that we had and setting the mode to desirable. And we're going to put that same sequence of commands in for each of the switches. See here, I got a couple of command rejected errors. Let me try pasting it in again. Alright, so that time no errors. Again, a couple of command rejected errors. Pasted the commands in a second time, and now we are going to no shut all of the interfaces on each of them after we change the configuration. And now we're going to verify. Now we can see in the output that it specifies the protocol, whereas when we had configured them statically, it did not. We can see that we have SU, which means layer 2 and in use, and then the member ports in the last column. And then we have the same output on switch 2. And now to go to the other PAgP option, in which one side has desirable and the other side has auto. We actually don't have to change anything for switch 1. Because those are already set to desirable. I just have this config here just kind of for reference. And then for switch 2, we're going to have a command that says no channel group 1 mode desirable, and then another channel group command that sets the mode to auto. All right, so I'm going to shut down all of the interfaces on both sides, even though I'm only going to edit on switch 2. You see you get a whole bunch of notifications about the interfaces going down. And then I'm just going to cut and paste the commands into switch 2. All right, and now I'm going to no shut all of the links, and that should be all that we need to do to bring that back up. And then again, we have the same results of SU. And the same on switch 2 as well. And then we're going to get into the LACP protocol. Again, we will shut down the interfaces, and then we will no out the channel group 1 mode desirable command and change the mode to active with another command. And by the way, I don't know if I explained this if you're not familiar with it. The interface range command specifies these 4 ports. So gig 00 through gig 03. And then whatever command you put in after that is applied to all 4 of those interfaces. In this case, it's just shut down. And then we do the same down here. It's just no shut. All right, so here are the configs for switch 1. And again, we got a couple of the command rejected errors. Just paste the same commands in again, and then it takes them just fine. And the same thing for switch 2. Do show Etherchannel summary. We can see that we have the SU for layer 2 and up, and now we have the LACP protocol specified there. And the same thing on switch 2. All right, now the 5th and final combination that we're going to do is also for LACP, and this is going to be when one side is in the active state and the other side is in the passive state. And so we don't need to do anything for switch 1 in this case because those are already set to active. But on switch 2, we do have to change the mode from active to passive. So that's what those commands do. And just like with the other ones, we're going to shut all of the interfaces down on both sides. And then change the configuration on switch 2, and then we are going to no shut the interfaces and turn them back on. And then the Etherchannel summary again shows us that we are layer 2 and up with the LACP protocol, and we have functioning Etherchannel. All right, so that concludes this video. If you found this helpful, please consider liking and subscribing, and I'll see you in the next video.